Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining the Ethernet MAC address. The Media Access Control Address, or MAC address, is a 48-bit unique value that's assigned to every network device that supports the Ethernet family of Layer 2 communication standards. This includes both wired Ethernet as well as Wi-Fi. Now, this is an important part of understanding Layer 2 because the MAC address plays a fundamental role in many of Ethernet and Wi-Fi's operations. For example, the MAC address is involved in MAC address learning to populate the MAC address table to achieve correct frame forwarding, which is simply the mechanism of forwarding frames out of the appropriate ports. Address Resolution Protocol, or ARP, also uses MACs. It's used to resolve a MAC address from the destination IP address during encapsulation. MAC addresses are also used in port security, which allows us to allow or disallow a device on the network based on its MAC address. MAC addresses are also used in MAC address filtering, which lets us filter traffic based on source or destination MAC addresses. Spanning Tree Protocol, or STP, is a protocol used to disallow the creation of Layer 2 loops, and it too uses MAC addresses in its operation. And finally, MAC addresses are also used for client and access point identification and association in Wi-Fi connectivity. Now, these are just some of the mechanisms that use MAC addresses and depend upon the uniqueness of this address on every network segment. You can see from this brief list, which is by no means exhaustive, how important MAC addresses are in the operation of Layer 2 in Ethernet and Wi-Fi. Now, many questions may come up when we talk about MAC addresses. How is the MAC address derived? How is it assigned to devices in such a way so that there is never any duplication within a network segment? We'll answer all of those questions in this video so you can get a solid foundation on the theory of MAC addresses. This here is an example of a MAC address. Now, it doesn't look familiar, does it? Actually, a MAC address is composed of 48 bits, and each network device reads these addresses in binary. However, for us humans to manage these addresses, they are almost always written out in hexadecimal. And this is what this same address looks like in hex. Now, the convention for writing out MAC addresses in hex is slightly different depending on the vendor. Cisco typically uses 3 sets of 4 hex digits separated by a dot like this. On your Windows PC, you will typically see MAC addresses written out as 6 groups of 2 hex digits separated by hyphens like this. On Linux and macOS systems, MAC addresses are usually written out in the same 6-group format, but are separated by colons instead. And in most documentation, this third notation is the one you will see most often. But all of these formats represent the exact same 48-bit address, only the notation is different. There may be other notations as well, but these are the most common that you'll see. Now, the MAC addresses of all devices on a single network segment must be unique. Any duplication will break the operation of the network segment. How can we be sure that the MAC addresses of all devices on a single network segment are unique? Well, MAC addresses are assigned by the manufacturer of each device following rules set by the Institute of Electrical and Electronics Engineers, or the IEEE. Each MAC address is split into 2 main parts. The first 24 bits, or the first 6 hex digits, are called the OUI, or the Organizationally Unique Identifier. This part identifies the company or the vendor that made the device, like Intel, Apple, Cisco, Samsung, or anyone else. Each company is assigned 1 or more of these OUIs for use with their devices. In most cases, large companies will have multiple OUIs assigned to them. So you will never have the same MAC address assigned to 2 devices from 2 different manufacturers, because the first 24 bits are necessarily different. Now, this leads us to another useful fact. You can identify the manufacturer of a network device by reading its MAC address and looking up its OUI. There are many online utilities that will allow you to discover the manufacturer of your device based on the MAC address. Now, the last 24 bits are assigned by the manufacturer as they see fit, and they are responsible for making sure that this part is unique for every device they produce. So in theory, no two devices in the whole world should ever have the same MAC address. MAC addresses are also known as physical addresses, or sometimes burned-in addresses. This is because historically the MAC address was programmed into the network interface by the manufacturer and stored in non-volatile memory, which persists across reboots. Also note that MACs are not assigned per device, but typically they're assigned per interface. If a server, for example, has 2 network cards, each one has a unique MAC address on the network. Now, for devices like switches which have many ports, some vendors will have a separate MAC address for each port, while other vendors will have one MAC address that corresponds to all. But this doesn't really affect the operation. MAC addresses of the switches themselves are only important when the switch is the source or the destination of a frame. For frames that are transient, meaning those that come into the switch simply to be switched, the MAC address of the switch itself plays no role. Now, all of this does not mean that the MAC address cannot be changed. In practice, once a device boots up, it reads the MAC address from hardware into memory. From that point on, the operating system can override that MAC address with a different value, a process known as MAC spoofing. Now, this can be used legitimately or as a method of malicious attack. So while the original factory-assigned MAC address still exists in hardware, the active MAC address used by the system can be modified in software. Now, some of you may be wondering, what about virtual devices? Like virtual machines or containers, they don't have physical network cards. So don't they still need MAC addresses? Well, yes, they do. Any device that communicates on layer 2, whether a physical device or a virtual device, must have a MAC address. Virtual devices are assigned virtual MAC addresses when they boot. These are generated by the hypervisor or the container platform that's running them. And even these virtual MAC addresses follow IEEE rules to avoid duplication on a network, specifically by using what's called a locally administered address, or an LAA. An LAA is a MAC address that's assigned by software or a network administrator rather than by a hardware manufacturer. It's indicated by setting a specific bit in the address, telling devices that this MAC is locally created and not necessarily globally unique. This bit is called the UL bit, or the Universal Local Bit. It's the second least significant bit on the first byte of the MAC address. In other words, it's the second bit of the whole MAC address itself. If it's a 1, the address is locally administered, or software generated. If this bit is 0, the address is universally administered, or factory assigned. This particular address here that we see is a locally administered address, since this bit is set to 1. Now, all of these rules are in place in order to mitigate against the possibility of duplicating a MAC address in a network segment. However, in practice, duplicates can still happen, either by accident or purposefully, because of software bugs, virtual machine misconfigurations, or MAC spoofing. But under normal conditions, if these rules are generally followed, MAC addresses are designed to always be unique within the segment. So those are MAC addresses, unique addresses on each individual segment, allowing layer 2 connectivity and a whole series of layer 2 mechanisms. Well, if you made it this far into the video, I want to thank you deeply. That tells me that you really care about understanding this stuff, and I appreciate that. If you want to go deeper into these topics, I've recently launched my website at telecomTech.io, where I'm building full courses with labs, quizzes, and real-world configurations. There's already a course there on layer 2 stuff that goes much more in depth than these videos here, and many more are on the way. Check it out, subscribe to the newsletter, and you'll get early access and better deals on future releases. I'm Lazarus at telecomTech. I hope this video has been helpful for you, and I'd like to thank you for watching.